So this build an atom game, this is just a refresher, okay, to refresh our memory. And so I'm gonna start here. Sam, can you tell me what goes in the nucleus? Which of these at the bottom of the nucleus?
Hold on 1 second. I'm looking through my notes.
Okay. Can you see my screen? Okay. You want to take a guess at which one of these? I know you know at least one of these. Like, which ones go in the center? Can you tell me at least one?
I'm gonna go neutrons.
Yes, neutrons does go in there. All right. And then let's see. Isaac, can you tell me what other thing goes in the center of the nucleus?
Can't you put maybe a proton? Or no?
I think it is protons. Very nice. All right, great. So protons and neutrons go in the center. So this is just a refresher, right? So good. All right, so that means electrons go on the outside. Okay, they go on the outside. All right, and then let's see. All right, let's talk about identity. All right. Josh, do you remember which of these three give me the identity of the element? Proton, neutron, or electron? And if you guys chat, you'll have to chat to everyone because I can't.
Oh, it's the proton.
Yes, very nice. The proton is what gives us our identity, okay? So remember, if I put another proton, look, it changed to helium. I put another one and changed to lithium. Lamar, are you there?
Yes.
Okay. Can you tell me which one of these has a negative charge? Proton, electron, or neutron? Which one has a negative charge?
Electron.
Electron, very nice. So if I add an electron, okay, that is one of the things that affects my atom, okay? All right. So who remembers where all of the mass is in an element? So we have our mass number right here. Where's all of the mass in the element?
In the nucleus?
Yes, it's in the nucleus. Very nice. Okay. So in the nucleus is all of the mass, and that means that's how we get our mass number. Okay. So if you notice here, I've got 1, 2, 3 protons and 1, 2, 3 neutrons. So that's 6, and that's why my mass number is 6. So only if I add a neutron, so I'm looking at this mass number right here. If I add a neutron, oops, okay, or a proton, anytime I add protons or neutrons, my mass number is changing, okay? All right, and then remember for my charge is affected by, well, let's see, Lamar told us that electrons have a negative charge. Can somebody tell me who has the positive charge?
Protons.
Protons have a positive charge. Very nice. Okay. So that's why if we look at charge, we're going to be looking at protons and electrons. So let me reset. Let's just look at that now. Okay. Let's look at just charge for a second. If I add a neutron, nothing happens. Doesn't matter how many I add. If I add a proton, we got +1 charge. It's 2 protons +2, 3 protons +3. Now, if I add an electron, that cancels out one of these. So I have a +2 charge. You can see these cancel out. I would need 3 of these for it to be neutral. Okay. And remember, if it's not neutral, it's called an ion. Okay. So if I have more, right now I have 3 electrons and 3 protons. If I have more electrons, now I have a negative charge. So this is a -1, -2. You can see right here, I have 2 more electrons than I do protons. Okay. And I know some of you guys are like, I know this. We're just trying to refresh. Okay. All right. So I can add more protons and get back to neutral. Okay. All right. So today, this is kind of what we're going to be learning how to draw, kind of, sort of, okay? It's a little bit more detailed, but not a lot. All right, so now let's switch to this screen. So remember, this is our little box with our different numbers, okay? So here's what gives me, I put a proton in, that gave me a number, that changed every single thing, okay? Who remembers which one of these numbers, top left, top right, bottom left, which one is my number of protons?
Is it top left?
Top left includes protons, but it's not just protons. Which one is just protons?
Isn't your protons like the number, like the same number your mass number is?
Not quite. Okay, not quite. Your mass number does include your number of protons because that is part of the mass, but your mass number also includes your number of neutrons. So let me add a neutron. You guys can see which number changes. So look here. Let's look at what changes when I add a neutron. Okay, so I added a neutron. I'm going to add another neutron. And now I'm going to add another proton. So now, based off of that, can you tell me which number is just your number of protons? Now, which one do you guys think is just your number of protons?
Bottom left.
Yes, bottom left, okay? And the bottom left number is just your protons. And does anybody remember the name of that? So remember, we had 3 names. They all were very similar. One was atomic mass, one was atomic number, and one was mass number. Okay. So which one tells us, which one is the number of protons? Atomic mass, atomic number, or mass number?
Atomic number.
Yes, atomic number. Very good. So this is my atomic number. Okay. This is my protons. All right. This one, adding protons is going to change this number and the element. Okay. It will also change this top left number, but I also need to have this number too. I also need the number of neutrons to change that. Okay. All right, so that means this one's the charge. So right now I've got 1, 2, 3, 4, 5, 6 protons. So if I want to make this 0, can somebody tell me how many electrons I need to add? If I want to make this number 0.
6.
6. Let's try. 1, 2, 3, 4, 5, 6. Very nice. Okay. All right. So this number is our charge. Okay. This number is our mass number. If you remember, we had something called man. Let me see if I can annotate. I'm going to try. All right. So remember, we had something called man. It was M. That was our mass number. A. That was our atomic number. And then if we subtracted them, what did we get? It was an N. What did the N stand for?
Is it the neutron?
Yes, it stood for the number of neutrons. Very nice. Okay. All right. So let's do a quick round robin of games. All right. I'm going to skip to, we'll do these 3 really quickly. I'm just going to call on people. So be ready to unmute, please. And then after that, we'll take a small break and then we'll jump into the notes. Okay. All right. Here we go. All right. Mass number. Kristen, how about mass number for this one? All right. And if you guys are rusty, that's okay, but we got to get there. Kristen, are you there?
Is it 4?
4? All right. All the mass is where, Kristen? Okay. Let's see, someone said something in the chat. Let's see. If I can get to the chat. Charles says 2. Let's try 2. Try again. 2. Very nice. All right. So mass number is all the masses in the nucleus. So there's 2 particles in the nucleus. There's 1 proton, 1 neutron. So that's 2. Very nice. All right. Total charge. And if you guys do in the chat, if you can do it to everyone, I can look on this other screen. Sometimes it's hard for me to get to the chat on this screen. Total charge for this one. Gabby says 1. Let's see. Very nice. There is nothing for us to offset that, nothing for us to offset this proton. All right. We got a mass number. Mass number. Anybody for the mass number on this one? Here it says 10. I got 10 and I got some 22s. Ooh, I got 10s and 22s. All right. So 10 would be just my protons. That would be my atomic number, but let's try this 22. Very nice. So the mass number is going to be your protons and your neutrons, protons plus neutrons. So very nice. All right. Total charge. Be careful. This is charge. Total charge. I know we all are a little rusty. Just a little bit. All right. Michael, how about charge for this one? You want to try this one? Remember, charge has to do with your positive and negative stuff.
It'd be -2.
-2, Charles. Michael says he is correct. All right. 8 protons, 10 electrons. I have 2 more electrons. Remember, those are negative. Then I do protons, so -2. Very nice. All right. And then mass number for this. Mass number for this one. So let's see. You guys can either put it in the chat or let's see who I can call on. Kanye, are you there? Very nice. All right. So everybody in the chat, I see a lot of people putting 4. Zarina, Stephanie, Sage, K Layers. Let's see. Very nice. Good job. All right, so that is 4. We're just looking at the stuff in the middle. The ones on the outside do not, they have mass, but they're so small that we don't even count it, okay? All right, so let's go back to the, all right, so let's try this one. And then we'll get ready to take a little bit of a break. All right, so here, all right, we got, we're looking for this number in the bottom, All right. What number do we want to put in the bottom? Kaya, what do you think? Number in the bottom. Oh, let me see. She said 1. She is correct. Very nice. All right. We're looking for this top number. I'll take anybody, or let's see, who could I call on? Kanye, are you there? I didn't hear from you the last time. Let's see. Who's in my chat? Mohammed, do you have this one? How about this top number, Mohammed? Oh, we got some people in the chat. I'm sorry. We got some 14s. Oh, Sage says 29 though. We got 14s and we got 29. Mohammed, what do you think? 14 or 29?
14.
14? Let's see. Oh, okay, let's try, Sage said 29. So let's try Sage's, let's see. Very nice, Sage, good job. All right, so remember this one, this top number, and I know we're all rusty, so no one should feel bad if they miss this stuff, okay? We're rusty, that's why we're reviewing before we get into this stuff, okay? Remember this top number is the mass number. And so your mass is your protons and your neutrons. Nice. All right, here we go. Looking for a charge on this one. Looking for a charge. Let's see. Elmer, what do you think for the charge on this one? What do you think? Elmer says 6 for the charge. Okay, 6. So positive 6 or negative 6, Elmer? I didn't ask you, I'm sorry. Positive 6 or negative 6? And think about what your positive and your negative stuff are. Positive 6, here we go. Uh-oh, okay, so let's look again. So let's look at how many negative things we have. Those are your electrons on the outside.
It's
Okay.
neutral.
All right, so I got a couple of people that say neutral. Let's try again, all right? Let's see. And it is, so let's talk about why it's neutral, okay? So, and again, no one should feel bad for missing anything. We're all rusty, okay? So there's 2 electrons, so that's 2 negative charges. And then there's 2 protons, which is 2 positive charges. So they would cancel out, so that would be 0. So let's see if we can, so here's another charge one, okay? So everybody think about this think about it just for a second before you put it in the chat, all right? So everyone can have a chance to think about it. All right, so think about what your positive and your negative stuff is. All right, I'm open. I'm looking at the chat now if somebody wants to look. Okay. Kayla says -2. Oops. She says -2. I believe she is correct. 16 protons is going to cancel out with at least 16 electrons. That's going to leave 2 electrons left over. -2. Very nice. All right. Last one. Remember, this one's your mass number. This is your mass number. So let's think about what's at where all the mass is and how many things you see. Okay. Jasmine says 3. 2, 3. She's correct. Very nice. All right. So here's what I would like for us to do. We are going to, you guys did a good job on that. I know we're a little rusty, but that's okay. I just wanted to do a quick review. Let's take about let's say 5 to 7 minute break. Okay, so let's just say 8:40. We'll just say 8:45. So that's a few minutes. Okay, so if you need to use the restroom, go get something to drink. I'm gonna go get some coffee. Okay, we'll take a break and then we'll come back. We'll get started at 8:45. We are going to be working on the notes. So I want you to figure out how you're going to take your notes. If you're going to take them in the notebook, go ahead and have this pulled up. Okay, I'm going to be on my screen, so I'll be writing it on my screen. You can write it on yours. So if you want it in your notebook, okay, or if you want to do it on the Google Doc, you can do it on there. If you're going to do it on paper, whatever you're going to do, just have that ready at 8:45. Okay, so you guys take a break. All right, so we're going to get ready to take some notes. I'm going to be doing them from my iPad so you can see me taking notes. And you should be taking them either on your OneNote or maybe you opened Schoology and went to the Google Form version of the notes or the, sorry, Google Slides version of the notes. or on notebook paper, okay? Whatever you need to do. Let me just preface this with this unit, there is a lot of, it's not a lot of math at all, but it's a lot of stuff that requires you to write out. We're going to have a lot of assignments where you have to upload stuff, okay? Because it's not something that I've figured out how to do multiple choice. So I'm legit going to have to check your work, okay? So I would make sure that I am taking good notes today. It's not anything hard, but it's easy to make a simple mistake, okay? All right, so let me switch my screen. Let me share my screen here. All right. Let's see. There we go. All right. So we are on this Bohr diagram of the atom, okay? And so one of the things that we didn't talk about a lot is the different versions or models of the atom, okay? So just like you have different models of a car, like how they change over the years, like, you know, maybe a Honda Civic in the 80s versus the 90s versus the 2000s. Oh my gosh, versus the 2020s, I guess, since we're in the 2020s now. They all look different, okay? So the same thing happened with the atom. Over the years, scientists changed or they got more knowledgeable about how the atom looks, right? Because it's something that we can't see. So this particular diagram is from a scientist called Niels Bohr. And he kind of thought like the atom was just this big, he thought it looked like the planetary model. Now, when you think about the planetary model, okay, you should be thinking about the planets. And what's in the center of the solar system? What's in the center? Or what do the planets revolve around?
Oh, the sun.
The sun, okay? So that's kind of how he thought about the atom. He was like, oh, there's this sun in the middle, which would be the nucleus, and then the electrons revolve around it. That's what he thought. Okay, so we call that the planetary model, okay? So let's go ahead and get started, all right? So this says atoms can, so this is us learning how to draw an atom. That's what this lesson is about, okay? So that we can represent isotopes and ions and atoms, okay? So it says atoms can be represented by Bohr diagrams, and Bohr diagrams are useful for better understanding the properties of an element and for predicting how an atom can combine with others, and this is to form compounds, okay? So we've been talking about the atom, all right? We've been talking about the atoms, but we've yet to talk about when atoms start to form with other atoms, okay? To form compounds. So we talked about how you had an element, and then when you have two or more elements put together, they form a compound. So this diagram kind of helps us to see how that happens, okay? So I'm going to put an important note up here that I didn't before. The proton tells us the identity of an atom or an element. The electron is important because that's how we learn about the properties of it. So one tells you about the identity and the other one tells you about the properties, okay? All right. It says, in this model of the atom, I'm going to zoom in so you guys can see a little bit better. There we go. All right. In this model of the atom, the electrons travel around the nucleus in well-defined circular paths known as, and there's a ton of things. You guys have heard me call them all kind of stuff. So I'm just going to write down a couple of them. You have orbits. You have energy levels. Anybody remember what else I've called them? Shells. And then usually what you hear me say is rings, okay? All right, but any of those, if you say orbits, energy levels, shells, rings, it's just where the electrons are. So this is, you don't have to do this, but I'm just showing you, this is where the electrons travel around the nucleus, okay? All right. All right. So now we're going to talk about how to draw the Bohr diagram. It is not anything difficult, okay? It's only going to take us a couple minutes to do these notes, and then we'll do some practice problems together, okay? All right. We only use this for the first 20 elements, and I'll explain why a little bit later, okay? So we're going to draw a circle for the nucleus, and inside we're going to write the letter, oops, we're going to write P and N inside that circle. Any guesses what the P stands for?
Protons.
Yeah, protons. Okay, so that stands for protons. And then the N stands for neutrons, because that's what's inside the nucleus, all right? You can write it next, you don't, I'm just letting you know, but you guys should know what P and N stand for. All right. Then it says, use the atomic number. So I'm on step number 2. Okay. It says, use the atomic number to determine the number of protons, because that's what the atomic number tells us. So remember, the atomic number is the number of protons. Okay. I'm just doing this so you know that these are the same thing. Okay. If you can't highlight or you're having a hard time highlighting, that's okay. All right. Use the atomic number to determine the number of protons and write that number next to the P inside the nucleus. Okay. And we'll go back and actually do one of these using the steps. Okay. Then it says use the provided mass number. So on step number 3, use the provided mass number next to the element symbol or the rounded, forgetting to change that. The rounded atomic mass if the mass number is not provided. So that's important. That's if the mass number is not provided. If I give you a mass number, you have to use it. But if I don't, then you have to use the rounded atomic mass. And I'm going to go back and explain this in just a second. To determine the sum of protons and neutrons. All right. So remember, if we're doing, sorry, I'll let you guys write. Right. So remember, if I give you a mass number, that's like me saying, and we'll do this for an example later on. Mass number next to the element symbol would be like me saying aluminum 30. Okay, so that's like a mass number. If I don't give you that, if I just say aluminum, then you have to go on the periodic table and find the number at the bottom. And you have to round that correctly. So for example, if I don't give you that, if we were looking at a box, okay, if we were looking at a box for aluminum, I'm just showing you what number you would use if I didn't give you the 30. Okay, so this would say aluminum, I think aluminum is number 13, I think. And I think this number is like 26.98. Okay, I don't have my Chem cruncher next to me, but I think that's right. Okay. So if I didn't say aluminum 30, okay, if I say aluminum 30, then you would use the 30 because that number tells you protons and neutrons. If I don't tell you aluminum 30, if I just say aluminum, we're going to use this number right here and we have to round it correctly to a whole number. So if I round this correctly to a whole number, what would it be, 26 or 27? If I round this correctly, 26 or 27?
27.
It would be 27, okay? So then I would use the 27, okay? And I'll show you, and this is just to calculate protons and neutrons. Now we already know protons because we know that this number right here tells us protons. okay? So then we'll talk about how to get neutrons when we do you guys know how to get neutrons, but we'll go over it again, okay? All right, so we're on number 4. Subtract the number of protons from the mass number or the rounded atomic mass to determine the number of neutrons. Okay. So if I know that aluminum is number 13, then I would subtract it either from that 30, if from the mass number or from the rounded atomic mass. Okay. All right, so most of that, and then you will write that number next to the N inside the nucleus. All right, so that's nothing hard. In other words, long story short, figure out how many protons you got, figure out how many neutrons you got, write that inside of the circle with the P and the N. Okay, so that's all we've done so far. All right, here's the new thing. Okay, draw the correct number of shells or levels or rings or energy levels, or whatever you want to call them, around the nucleus. Okay, now here's how we do that. The row, okay, or we call them periods. The row or period of the element in the periodic table is the number of shells you need. Okay. All right, so let me see if I can find my Chem Cruncher. Let me see if I can see where it is, and I'll tell you guys. I just want to show you. Okay. All right, so for example, all right, if I'm looking at, let me see if I can. All right, so for example, if I'm looking at my elements, okay, so remember a sentence, at the end of a sentence, you put a period and you read a sentence left to right, okay? So basically, if I were to number these, this is the first period, okay? Remember, periods go this way, left to right. This is the second period. So if I asked you where carbon was, carbon's on the second, we'll get 2 rings, all right? This is the third. Okay, this is the fourth. I got you, Chuck. This is the fifth, and so on, okay? So like sodium right here is we get 3 rings. Chlorine, 3 rings. Helium, 1 ring. So that's what I mean by that, okay? All right, any questions about the period? So that tells me how many shells I would get. All right. So then we have to determine the correct number of electrons to be drawn, okay? So the number of electrons is equal to the number of protons if your atom is neutral, okay, if it's neutral. In other words, if I don't tell you that it has a charge, then you already know how many electrons you have. It's the same as the number of protons, okay? All right, so basically, when we get ready to draw this, figure out how many protons, neutrons, electrons you have. Figure out how many rings you have, which is based off of where it is on the periodic table. And then we're going to talk about how to draw in these electrons, okay? All right, so now we're going to do this, and then we're going to do some practice problems because we're almost done with the notes, all right? On this first level, closest to the nucleus, that first ring can only hold 2 electrons. That's all it can hold, okay? All right, the second one can hold 8, and the third one can hold 8. All right, now let me tell you how we fill them in. Okay, so earlier Lamar told us that electrons have a negative charge. What if I have something with a negative charge, what would it be attracted to? Something with a negative charge or something with a positive charge?
A positive charge.
A positive charge, right? Because opposites attract, okay? Opposites attract. In other words, it's really interesting if you think about it. The electrons actually want to be as close to the nucleus as possible because the nucleus has a positive charge, okay? So the electrons try to get as close to it as possible, okay? So that's why they fill in a certain way. That's why the electrons always start and they fill in closest to the nucleus first, and then they kind of eventually branch out, okay? And we're gonna talk about this whole unit, we're gonna talk about why electrons fill in the way they do and all that good stuff, okay? So I'm gonna tell you in so many words how we fill them in, and then you can fill in this part that I just marked how you want to, okay? But basically, when we fill them in, we want to space the electrons far apart, okay? So typically, when we fill in, we're going to fill in, you don't have to write this yet, fill in clockwise, then in pairs, okay? And I'll explain to you what I mean. So this is how I typically fill it in: 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. And I know that sounds weird, but let me show you and it'll make more sense, okay? So I'll give you a second. Okay, so this is like pretending that this is a clock, right? So there's really like a 1 and a 2 o'clock, and we're gonna fill them in at the 12 o'clock space, 3 o'clock space, the 6 o'clock space, and a 9 o'clock space if this was a clock, okay? All right, let's get ready to do some examples. I think they'll make more sense once we start doing them. They're really kind of easy, okay? All right, so now if you've taken your notes, you do want some paper because you're gonna have to draw, okay? And that's what, when we get ready to do our quiz on Monday, our homework quiz that we usually do in class, you're gonna have to draw and you're gonna have to upload because there's no way for me to make this multiple choice, okay? All right, so I'm gonna go over here to the side. I'm gonna try to keep my notes up so you can see them. All right, and I'm gonna let's just do that example we were talking about, aluminum 30, okay? Let me do something a little bit brighter. Aluminum 30, okay? So it would say something, for instance, on your homework, it's gonna say something like, draw a Bohr diagram for whatever. And it may say aluminum 30, or it may be an isotope, or it may just be an atom, okay? So what I would do first is I would say, all right, I need to figure out how many protons I got, how many neutrons, how many electrons, and how many rings, okay? So this is all the stuff we need to figure out. All right. Let me zoom in so you guys can see that better. All right, so aluminum 30. Can somebody tell me how many protons aluminum 30 would have? You do need your Chem Cruncher, okay, if you don't have it. You'll need your Chem Cruncher for the rest of this year.
You mean the periodic table that you
Yes, yes.
Okay.
Can somebody tell me how many protons aluminum has?
13.
13, very nice. All right, so aluminum has 13 protons, all right? Now, there's nothing indicating, there's no like plus something or minus something up here. So there's nothing indicating that this has a charge, okay? And if it doesn't have a charge, that should mean that the number of protons and the number of electrons are the same. So I'm gonna go ahead and write 13 electrons too. And that's only because there's no charge on this, okay? Now, I gave you a mass number on this, okay? I gave you a mass number. Let me find something a little bit brighter. This pink is bright, all right. So remember, this number right here is a mass number, all right? And this mass number tells you protons plus neutrons, okay? So if I know that this is protons plus neutrons, and we just figured out that I have 13 protons, then if I subtract these two, I should get my number of neutrons. So what's that leave me with? 30 minus 13.
17.
17, very nice. All right, so now I got 17 neutrons. All right, so now I just need to know how many rings I have, okay? All right, so I'm going to go to my here, and I'm gonna look, and I can see that aluminum is on the third row. It's on the third row, okay? So that means I need 3 rings, all right? So I need 3 rings. 3 rings. All right, so here's what we're gonna do. We're gonna follow our directions. It said to draw a nucleus and put P and N in the center. Okay, so I'm gonna draw a nucleus. I'm gonna put P and N in the center. I got 13 protons, so I'm gonna put 13 right there. 17 neutrons, so I'm gonna put 17 right there. Now I need 3 rings. This one does not count as a ring. This is the nucleus, okay? So I'm gonna draw 3 rings. 1, 2, 3. All right. Now I need to do 13 electrons, 13 electrons. Now, when I go back over here, it told me, all right, my first ring can only hold 2 electrons. My second one can only hold 8. And the third one can hold 8. All right, so I need to fill in 13 electrons. So the first one can only hold 2. So I'm going to put 2. I'm going to put them as far apart as I can because they don't want to be next to each other, okay? And what we're going to learn later is that electrons really have like a little tail. So they can pair up because they rotate, but if it's just one by itself, it doesn't want to be there, okay? All right, so that's 2. Remember we said we're going to fill in like 12, 3, 6, and 9 o'clock, okay? So now that's 2 rings, that's 2 electrons. I still got 11 to go. So that's 2, here's 3, that's at 12 o'clock. 4, 5, 6, that's 6 electrons. This ring can hold 8, so it's only got 4 now. So I'm going to go back and put one next to this one. I'm going to pair them up. So this is 1, 2, 3, 4, 5, 6. This is 7, 8, 9, 10. I'm trying to get to 13. So I'm at 10 electrons now. I need 13. So that's 10, 11, because that second ring is full. It can only hold 8. 12, 13. And we're all done. So now when I look at this, I can tell, I should be able to tell that this is aluminum 30. Aluminum 30, okay? All right, let's try to do another one. All right. All right, let's try, how about, let's try draw carbon. So all I'm gonna say is draw, the instructions would say something like draw a Bohr diagram for carbon. Oops, draw a Bohr diagram for carbon, okay? So we still need to figure out how many protons, neutrons, electrons, and rings we have. All right. I did not give you a mass number this time. Okay, did not give you a mass number. Did not give you anything indicating charge. Who can tell me protons? This is carbon. Serena, do you know how many protons carbon has? Yes, very nice, Kayla. 6. All right, and there's nothing indicating that carbon is charged, so it's going to have 6 electrons too. All right. I didn't give you a mass number, so that means we have to look at what it looks like on the periodic table. So on the periodic table, I think it says 6C. I think this is 12.011, I think, something like that, or 12.01. All right, so this time we have to use this number because I did not give you guys a mass number. Okay. All right, anybody know number of neutrons or rings for carbon?
Is it 6?
Yes, it is 6 for neutrons. Very nice. Okay. It's 6. Oops. And that's because if I round this number right here, it's still 12. And then if I subtract, so I'm going to use this instead of the mass number, and then I'm going to subtract the 6 protons. And that leaves me with 6 neutrons. All right. And then what row is carbon on? First, second, or third row?
The second.
Second row. All right, so that's 2. All right, so now we can get ready to draw. We need our nucleus. P, N. P is equal to 6. N is equal to 6. And then we said 2 rings. 1 ring. 2 rings. Okay. And then we got 6 electrons. 6 electrons. First ring can only hold 2. 1, 2. Still got 4 more to go. All right. So that's 2. This is 3. Or you can say 1, 2, 3, 4. There we go. All right. 1 more. And then we'll do a little bit of practice on Monday. And then you guys are going to have to do 5 of these. Okay. 5 of these. You're going to have to do it on paper and upload it. So make sure you know how to do it. All right. Let's do. Yes.
For the first row, is it okay if they're on the side and not up and down?
Are you saying, oh, are you saying yes? Are you saying like here instead of up and down?
Yeah.
Yes, that's fine.
Okay, thank you.
Mm-hmm. All right, so let's do 1 more. Let's make it kind of, let's do, how about Bohr diagram, draw a Bohr diagram for, let's do like, let's do an easy one, or kind of easy. Let's do, all right. So we still got to figure out protons, neutrons, electrons, and rings. I'm not going to say this is the easy one necessarily. All right, but let's see if we can finish this before the bell rings, okay? All right. Protons. Anybody for protons? Very nice. 1 proton. That is correct. All right. I'll take anything else. Neutrons, electrons, or rings. Whatever you know. How about rings? What row is it on? Somebody tell me. We're gonna run out of time. You guys aren't gonna be able to, you want to see this before you do your homework on it. Somebody tell me how many rings. What row is it on?
The first row.
It's on the first one. So that's one ring. All right. Let's see. Neutrons, the way this is set up, I can say 2 minus 1 leaves me with 1. So there's only one neutron. All right, so I did 2 minus 1 equals 1. All right, so that's my neutrons. And then electrons, I have a +1 charge. Got a +1 charge. I got 1 proton for sure. So if I have a +1 charge, I'm gonna go with 0. We don't have any electrons. Very nice, 0. All right, so now let's draw it. Nucleus, P. N, P is equal to 1. N is equal to 1. 1 ring. And, oh, no electrons. So 0. So this is it. Okay. This is how we do a Bohr diagram for 2,1, this isotope of hydrogen. Okay. All right. If anybody needs to see anything, I will scroll back up or scroll over it. Otherwise, you're going to have 5 of these that you have to do during class on Monday. 5 of these. And you're going to have to upload a picture, just a heads up, okay? I do want you to work on that isotope quiz in Schoology, just to refresh your memory. Remember I said, so that needs to be done before Monday. I'm going to have it set to be due. I'm going to have it set to be due on Friday night. So that gives you 2 days still, okay?
Will these notes be on under a link in Schoology?
I can put some of these. Yeah, they're in Schoology now. You mean like filled in?
Yes, ma'am.
I'll put these in your notebook under keys. I'll put them in your notebook under keys. Okay.